When people talk about the AI revolution, the same names keep coming up. Nvidia, OpenAI, Apple, TSMC. These are the companies on magazine covers, in earnings headlines, in every conversation about the future of technology. But the most advanced chips in the world, the ones that power ChatGPT, that train frontier AI models, that sit inside your phone and inside the data centers reshaping the global economy, depend on machines so complex that almost no one else on Earth can build them. These machines use ultraviolet light to carve patterns smaller than a virus onto sheets of silicon. They cost hundreds of millions of dollars each. They take years to manufacture. And essentially one single company in the world makes them. That company is not American. It is not in Silicon Valley. It is a Dutch firm called ASML. And if anything ever happened to it, the entire AI industry, every smartphone maker, every car company chasing self-driving, every defense contractor, every cloud provider would feel the shock almost immediately. So the question for the next few minutes is simple, but strange. How did one quiet European company end up standing at the center of the most important industry on the planet? And why have so few people ever heard its name? To understand why ASML matters, we have to step back and look at how we usually talk about AI. The story most people hear is a story of software. Massive language models trained on the entire internet, algorithms that can write, code, draw, and reason. But underneath all that software is a mountain of hardware. And that hardware is the part most people never think about. Modern AI requires absolutely enormous amounts of computation. Training a frontier model can consume more electricity than a small city uses in a year. Running it for billions of users takes warehouses full of specialized chips, custom accelerators, high-bandwidth memory, and networking gear designed to move data at almost unimaginable speeds. So when people talk about AI, they usually talk about the visible layers. Nvidia sells the GPUs. TSMC manufactures the chips. Apple, AMD, and Qualcomm design their own silicon. OpenAI, Google, and Meta train and deploy the models. Each of these companies is a giant in its own right, and each of them gets enormous amounts of attention. But every one of these layers, every single one, depends on something deeper. Someone, somewhere, has to actually build the tools that make advanced chip manufacturing possible in the first place. And that is where the story stops being familiar. Because once you ask, who builds the machines that build the chips, the list of candidates collapses almost instantly down to one name. ASML is a Dutch company headquartered in a town called Veldhoven, not far from the Belgian border. It is not a household name. But inside the semiconductor industry, it is treated with something close to reverence. ASML does not design chips the way Nvidia or Apple does. It does not manufacture chips the way TSMC or Samsung does. What ASML makes are the giant, almost unbelievably complex machines that chip factories use to print transistors onto silicon wafers. Think of them as the printing presses of the digital age, except instead of printing letters on paper, they print billions of microscopic switches onto a disk smaller than a dinner plate. And in the most advanced corner of this industry, the corner where the cutting-edge chips for AI and high-end smartphones are made, ASML has something close to a complete monopoly. The technology is called EUV lithography, short for extreme ultraviolet lithography, and ASML is the only company on Earth that makes machines capable of doing it at commercial scale. A single one of these machines can cost more than $300 million. Each one is roughly the size of a bus, contains hundreds of thousands of components, and has to be shipped in pieces using multiple cargo planes and trucks. When it arrives at a customer's facility, it takes a small army of engineers months to install and calibrate. And that is just to get one of them running. The world's leading chip makers order them years in advance and still can never seem to get enough. So what exactly does one of these machines do? And why is it so hard to build? Imagine a chip as a microscopic city. It has billions of tiny buildings called transistors, connected by an unfathomable web of streets, wires, and intersections, all packed into a space smaller than your fingernail. To create that city, the factory has to draw the entire blueprint onto a sheet of silicon, lined by impossibly thin line. The way they do this is a bit like a movie projector, but at an atomic scale. A pattern is shown onto the silicon wafer through layers of lenses and mirrors, and the light etches the design into a special coating on the surface. The catch is that the more advanced the chip, the smaller the details have to be. We are talking about features just a few nanometers wide, so small that ordinary visible light is simply too clumsy to draw them. The wavelength of normal light is bigger than the lines you are trying to make, like trying to write the words on a grain of rice using a fat marker. So the industry needed something with a much shorter wavelength, and that is where extreme ultraviolet light comes in. EUV is not just a stronger light bulb, it is a fundamentally different kind of light, and producing it is brutally difficult. To make EUV, ASML's machines fire a laser at tiny droplets of molten tin, 50,000 times per second, vaporizing them into plasma that releases a faint flash of ultraviolet light. The light then bounces through a system of mirrors so precise that, if one of them were scaled up to the size of Germany, the largest bump on its surface would be less than a millimeter tall. The whole process happens in a vacuum, because EUV light is absorbed even by air. Every motion is controlled at the level of nanometers. It is, by almost any measure, one of the most precise industrial processes humans have ever invented. Once you understand what is going on inside these machines, you start to understand why nobody else is making them. It is not that other countries and companies have not tried, they have. The problem is that EUV lithography is not a single invention. It is the combined output of decades of research and an unbelievably specialized supply chain. ASML itself does not even make all the parts. It is the integrator at the center of a vast web of suppliers. The optics, those impossibly perfect mirrors and lenses, come largely from a German company called Zeiss, which has a relationship with ASML so deep that ASML eventually bought a stake in part of the business. The light source technology came in part through Cymer, an American company ASML acquired years ago. There are thousands of other suppliers around the world contributing one specialized piece each, from custom sensors to vibration dampers to ultra-pure materials. So when people ask why China, or the United States, or Japan cannot just spin up their own EUV machine, the answer is not really about money. Even if you handed a competing country $50 billion and told them to catch up, they would still have to recreate the entire ecosystem. They would need the patents, which ASML and its partners have spent decades accumulating. They would need the operational know-how that lives inside the heads of veteran engineers. They would need suppliers willing and able to manufacture parts to tolerances that almost no other industry demands. And they would need the cumulative experience that only comes from building, shipping, and refining generation after generation of these machines. EUV is a textbook case of what people in the industry call deep tech. It is the kind of technology that looks harder the closer you get to it, not easier. So pause for a second and imagine something. Imagine that tomorrow, for whatever reason, ASML simply could not deliver any more EUV machines. Not because of war, not because of sabotage, just imagine the supply stops. What happens? At first, not much that the average person would notice. The chip factories already running would keep running, phones would keep shipping, data centers would keep humming. But underneath the surface, the clock would already be ticking. The most advanced chips, the ones that AI labs are racing to use for the next generation of models, the ones that power flagship phones and the most cutting-edge laptops, Those rely on a constant pipeline of new EUV machines to expand capacity. Without that pipeline, the whole industry's ability to scale would start to choke. New AI chips would arrive later, data center expansions would slow, cloud computing would get more expensive, self-driving cars, advanced medical imaging, defense systems, satellites, robotics, all of it would feel the squeeze. Within a few years, the entire trajectory of AI progress would visibly bend downward. So this raises an obvious and uncomfortable question. If a single company in a single country is this critical to the modern world, why on earth has the global economy allowed such a fragile bottleneck to exist in the first place? The answer is that the world did not really plan it this way. It happened slowly, through decades of competition, consolidation, and technical specialization, until one day people looked up and realized that advanced chips had quietly become a strategic asset on par with oil. And in that moment, ASML stopped being just a company and became a piece of geopolitics. Today, advanced semiconductors are not simply consumer products. They are the foundation of artificial intelligence, modern weapon systems, supercomputing, surveillance, and economic competitiveness itself. Whoever controls the most advanced chips arguably controls the commanding heights of the 21st century. And because ASML controls the machines that make those chips possible, it has been pulled directly into the great power competition between the United States and China. Washington has spent the last several years tightening export controls, pressuring the Dutch government to restrict what kinds of ASML machines can be sold to Chinese chipmakers. The most advanced EUV systems have been blocked from going to China entirely, and even older deep ultraviolet machines have faced new restrictions. Beijing, for its part, has poured tens of billions of dollars into trying to build domestic alternatives, with limited success so far. ASML sits awkwardly in the middle of all this. It is a Dutch company, but its supply chain is global, its customers are global, and the political pressure on it comes from many directions at once. The company did not ask to become a flashpoint in a superpower rivalry. Its position simply made it inevitable. Now bring this all the way back around to AI, because this is where the picture really clicks into place. People often talk about AI as if it were purely a software phenomenon, a matter of clever algorithms and big datasets. But AI is actually a stack, and that stack goes much deeper than most people realize. At the top, you have the data and the models. Below that, the software frameworks. Below that, the chips that run everything. Below the chips, the foundries that manufacture them. And below the foundries, the equipment that makes the foundries possible. ASML lives at that very bottom layer, the layer almost no one ever sees, and yet every layer above it depends on what happens there. Every step forward in AI demands more computing power. More computing power requires more chips, faster chips, more efficient chips, and chips with smaller and smaller transistors packed more densely together. That in turn requires more advanced manufacturing, which requires more advanced lithography, which requires more capable EUV machines. So while ASML does not write a single line of AI code, the pace at which AI can grow is to a surprising extent set by how quickly ASML can ship and improve its machines. They are not building the brain. They are building the factory that builds the brain. And this leads to one of the strangest truths about modern technology. The companies that get the attention are almost never the ones doing the heaviest lifting. The names everyone shouts about, ChatGPT, Nvidia, Apple, TSMC, are real and important. But they sit at the visible end of an enormous chain. The further down the chain you go, the more obscure the names become, until you reach companies like ASML, where almost nobody outside the industry can tell you what they actually do. ASML is a kind of symbol of a much larger truth, which is that the modern world does not stand on top of one big technology. It stands on top of a fragile, intricate web of dependencies. A smartphone in your pocket, a chatbot answering your questions, an electric car charging in your driveway, a satellite passing overhead. Every single one of those things at some point in its history passed through a machine like the ones ASML builds. Sit with that for a moment. A single company in a small Dutch city building the rarest and most complex machines on the planet, effectively setting the tempo at which chip technology can advance, and through that, setting the tempo at which AI itself can grow. It is one of the strangest and most consequential bottlenecks in the history of technology, and most of the world has no idea it is even there. The deeper lesson in all of this is that technological power is not always where you think it is. We tend to look at the surface, at the apps, the products, the brands, the founders giving keynote speeches. But the real leverage often lives much further down, in the tools that make the products. In the AI era, the winners will not just be the labs with the best models or the companies with the slickest interfaces. They will be the ones who control compute, chips, fabs, equipment, and the deep supply chains underneath. ASML matters because it occupies one of those rare positions in the global economy that nobody can easily replace. It is not the most exciting story. It is not flashy. There are no viral demos coming out of Veldhoven. But the future of AI may be written in code and trained in data centers and used through apps on your phone. And yet underneath all of that, it is being manufactured by machines that almost no one will ever see. If this kind of story is the kind you want more of, the kind that pulls back the curtain on the invisible companies quietly shaping the future, there is plenty more where this came from. Next on this channel, we are going to dig into how Nvidia turned itself into the single biggest winner of the AI boom, why TSMC became the most strategically important factory on the planet, and what the US-China chip war is really a fight about. Hit like if you want more videos on the invisible companies that control the future. Subscribe to follow the AI and Chips series as it unfolds. And in the comments, tell me which company you want me to break down next. Because once you start looking under the hood of the modern world, it gets very hard to stop.